as I said, we are trying to find the first derivative of y with respect to x, and also the second derivative with respect to x. We know how to find the first derivative. This is implicit differentiation because the function is defined implicitly, implicit differentiation. So I will start differentiating both sides of the equation with respect to x. For the right-hand side, I get derivative of y cubed with respect to x. That's 3. Don't write 3y squared. This, you have to apply the chain rule. 3y prime y squared. We are differentiating with respect to x. Plus, the second term, we need the product rule. So it will be 1 times y plus x times y prime. The third term is just 2x. Right-hand side is 0. Now, I have two terms with y prime. I put them together. 3y prime y squared plus xy prime. And put everything else on the right-hand side. Minus y minus 2x. And then from here, now I can factor out y prime. Oh, I factor out y prime, and then the next step is multiply the coefficient of y prime to the right-hand side. So y prime is equal to negative y minus 2x over minus y minus 2x. Well, the denominator will be 3y squared plus x. Okay, so that's how we find the first derivative, yes? Now, the question is, what is the second derivative? How do we differentiate y, which is implicitly given, twice with respect to x? Okay, here, what you need to know, or what you should remember, is that the first derivative, the second derivative is nothing but the derivative of the first derivative. In other words, if you want to find the second derivative, you first need to find y prime and then differentiate it again. Look, I have y prime. I can differentiate the whole y prime with respect to x. And whatever the result is, it's going to be my second derivative. Here, when you're trying to differentiate this, you definitely need to use the quotient rule. Derivative of numerator times denominator minus denominator time numerator times the derivative of denominator, and denominator squared. And while the derivatives are there, so minus y prime minus 2, 3y squared plus x minus y minus 2x times this guy here. The derivative is going to be 6y prime y and plus 1. And in the denominator, what we found is that the second derivative is equal to that. Well, when you look a little bit closely to this equation, you say that, okay, when I was trying to find the second derivative, I should have my equation. The final thing that I found must have only x and y in it. You see there is y prime here, and there's another y prime here. I don't like that. Neither do I. What should I do? Well, you pick this whole thing here and plug it in this final formula. So you will get minus y, okay, this is the whole thing, minus y minus 2x, 3y squared plus x minus 2, then 3y squared plus x minus y minus 2x, 6 times minus y minus 2x over 3y squared plus x times y plus 1 over 3y squared plus x. This way, I found a formula for the second derivative of y with respect to x when y is defined implicitly in terms of an equation.